Welcome into the weather review. I am Gavin White, and we have quite a bit of weather to review from this past week, actually. We're in the middle of February now. Happy belated Valentine's Day to you and yours. Another week has gone by. We are halfway through the month of February, which is a wild thing to think about. This month is flying by, as is this year already. Unbelievable. But we are very quickly approaching springtime, spring severe weather. That's when all of the action really starts to get going, kind of spring through the summer and the fall. I mean, really, there's weather 24/7. That's what makes it great. But a lot of the exciting stuff, I say that loosely, exciting as in a lot of the interesting stuff happens during the springtime. It's tornado season. That's when we get a lot of the strong, severe weather as jet stream sorting itself out as we're transitioning into more warmer temperatures nearing the summer, and things start to get really interesting here in the spring. We're going to start seeing that over the next month, more and more interesting weather. But kind of the start of that is in February. February is kind of that weird transitionary month here. We're kind of we're in the latter half of the winter. We're starting to tilt back. The Earth is starting to tilt back our way. We're getting a little more sunlight, a little more solar radiation every day, slightly, but it still adds up. We start getting more interesting weather here in February. And that has already come to fruition this last week. There's a large mid-latitude cyclone that was associated with a winter storm in the Midwest, and it ended up producing up to 3 tornadoes in the South. That's kind of what I mean. And that's what we're going to be reviewing today as well. Just as we're here in late February, we're getting into that strange weather. So kind of jumping on into this now. Just kind of some of the more notable weather from this past week. Really, there were two things that took place, both on Wednesday. One was on just Wednesday. The other event was kind of Wednesday through Thursday. It was like a 2-day event. And then we're going to focus more on that second event later on. But just kind of initially, just as a review of what happened, there was a relatively small winter storm over the mid-Atlantic on Wednesday, February 12th. What was interesting about that storm is it was a winter storm. There was a lot of snow. It was primarily concentrated. The strongest or the highest snow totals were primarily concentrated across north and central Virginia. That's kind of where the low, it wasn't really much of a low, but that's kind of where the heaviest precipitation tract was there, and it kind of tapered up towards Maryland. Maryland got some snow as well, as did parts of Pennsylvania and New York, New Jersey. But I was kind of on the northern end of where the heaviest snow was. That heaviest snow was in north central Virginia, kind of between Richmond and D.C. We saw a large swath of 5 to 8 inches, ranging from Charlottesville, Virginia, to Woodbridge, Virginia, even to just outside of Annapolis, Maryland as well. Just kind of a large, wide swath there, 5 to 8 inches, with some higher totals in the mountains. So it was a pretty solid snow event there, especially for a region that typically, only sees a few inches a year. They've already had 2 major snow events, and they might be getting a third this next week. We'll find out. But wanted to highlight that, as that was definitely an event, and that was kind of a precursor to this larger system that came through later on Wednesday and then throughout Thursday, and that's what I want to focus on today. It was a larger storm across the Midwest, and it continued into southern Canada. There were various amounts of snowfall ranging from Iowa to Illinois to Wisconsin to Michigan. Not an exorbitant amount. I mean, it wasn't feet and feet and feet of snow. We're not talking blizzard or nor'easter or anything like that. It was just a standard winter storm, snowstorm covering just a large part of the Midwest. But what's interesting about this system is that the most notable aspect of it was actually the severe weather that it triggered down south. So while the Midwest is getting all this snow simultaneously, in Mississippi and Alabama, there were 2 to 3 tornadoes. I don't think the third one's been confirmed yet, but I know for sure 2 have been. 2 to 3 tornadoes that occurred, 2 in Mississippi, 1 in Alabama, associated with that system's, the cold front coming off that system. And that's what we're going to dive into here. So this is interesting, in which it was a very unique system. There was a primary low, and then there was a secondary low. So kind of starting with that primary low. There was a low that began to, on Wednesday, there was a low that began to develop along the Mississippi River, kind of in the region of the Tennessee Valley. cold front became, as that low continued to develop, as that low continued to develop, the cold front started to become well defined, kind of extending from wherever the low was at the given time through the Tennessee Valley, and then down, reaching all the way down actually to the Texas coastline there with the Gulf. So it was a pretty extensive cold front with a decent temperature gradient, kind of reaching across that. And if you are watching this on Spotify as opposed to listening, you're seeing some of these maps as I'm talking about it, and hopefully you can see what I mean. But it was a pretty extensive cold front as this low continued to develop. It continued to strengthen. It continued to intensify, and it continued to strengthen throughout Thursday. And Thursday is when the low really started to deepen. And when I say deepen, the pressure within the low pressure started to drop. It's when it dropped below 1,000 millibars, which is kind of considered your standard sea level pressure. It dropped below that, which is an indication that it is a pretty strong system. We saw it continue to drop as it crossed into Canadian territory and it continued northeastward throughout Thursday, and then I don't care about it after it leaves the U.S. because that's what this is focused on. That's where the most of the impacts were as well. But it was a pretty robust low system that kind of developed throughout Wednesday and Thursday especially. But what was interesting about that, kind of focusing on that cold front coming down to the south from that low, that center of rotation is associated with the low pressure, from the south kind of extending downward, that arc, that cold front, where temperatures behind it or to the west are colder than temperatures to the east because it's moving eastward and bringing cold temperatures with it. But along that cold front, there was a secondary southern low that began to develop, kind of along. So I'm gonna categorize this by the primary low, which is the bigger system, which is what brought the snowfall into the Midwest, and then the secondary low, which is what's responsible for the severe weather down south. They're connected. They're related to each other. Along the primary low's cold front, secondary region of circulation began to form over the Louisiana-Mississippi border. It started to become well-defined as it traveled and traversed over Mississippi. Later on Wednesday night, secondary low eventually had its own cold and warm fronts, as is the primary low. So that's kind of one of the defining features of a mid-latitude cyclone, is when you have a center of rotation or a low-pressure system with a cold front extending either to the west or the south or the southwest, and then a warm front extending generally out to the east. That's kind of the defining characteristic of a mid-latitude cyclone, which is what's responsible for the vast majority of weather patterns in the United States. And severe weather and normal weather, it comes down to that mid-latitude cyclone, and that's kind of what we're discussing. And again, if you're watching on Spotify, you're seeing this. And if you're just listening to me, hopefully I'm doing a good job at describing this. But we get that low pressure, secondary low pressure, and it begins to form its own cold front, its own warm front. And we can kind of see it interact with the mountains there. It doesn't really want to go over the mountains, because it's not really as strong as the primary low. But it is strong enough to control its own fronts, which is interesting. It's moving air on its own despite being in proximity of the primary low's cold front. So along the secondary low's cold front, which is really just an extension of the primary low's cold front, but we're talking about the section of the cold front that's extending from this new formed low pressure over Mississippi at this point in time. We start to see some storm initiation. This is generally going to occur just ahead of the cold front, as the cold front pretty much acts as a forcing mechanism. So the cold front's coming along, and it's cold front, so it's colder air coming. Cold air is much denser than warm air, so as it's coming, it's wedging itself under the warm air, which is forcing the warm air up, and then it starts to rise. Warm air is less dense, so that's why it's going to rise. But we're talking about kind of in the region where we are, there's a lot of moisture in this region. So this is warm air with a lot of moisture. It's fairly buoyant. All it needs is a little shove, a brotherly shove, if you will. And that sucker is going to start rising. And all it needs is that initial momentum to get it going. And once it's going, it's going to take care of itself as it continues to rise higher and higher into the atmosphere. What's so significant about that is that as it rises higher and higher, it's going to start to condense. All that moisture, there's so much moisture in there, it has to get rid of it somehow. It can't hold that much moisture. As it rises, it starts to condense, starts to create clouds, continues to rise. The clouds get bigger, the clouds get taller. Starts to form precipitation. It continues to rise. The precipitation gets heavier. We start seeing thunderstorm development, so on and so forth. That's why it's so significant, why we see so many severe weather outbreaks kind of along or ahead of these cold fronts as they come along. It's forcing the air to rise that otherwise isn't going to rise unless something forces it to. But one of the defining characteristics that allowed this to become severe weather as opposed to just ordinary rain showers or even just a calm thunderstorm is the presence of wind shear in the region. Now, wind shear is a change in wind speed and or direction with height. So as we're going higher up into the atmosphere at a given location, the wind is coming from different directions, or it's blowing faster, or it's doing both. And that's pretty significant because if you have wind coming from different directions as you're going higher up in the atmosphere, you're getting natural rotation in that region. Which is pretty significant for severe weather, for tornadoes, for supercells, which is the most common type of storm that a tornado is going to form from. And we actually saw that here in this instance. There's some pretty significant wind shear, in my estimation, in this region where we saw these tornadoes develop. So ahead of the cold front, I'll throw this map up as well. Ahead of the cold front, we kind of see in that Louisiana, well, not even, yeah, in Louisiana as well, but really in the Mississippi, Alabama area, which is where we saw these tornadoes occur. We kind of see from at the surface, so kind of just above the ground, the winds are coming out of the southeast. There's a little bit before the tornadoes form, but generally the environment around this time. At the surface, at the ground level, winds were coming out of the southeast. A little bit higher at the 850 millibar level, so that's talking about at the height at which the general average pressure is 850 millibars. Surface is about 1,000. You go higher, pressure decreases. So at 850 millibars, which is about 5,000 or so feet above the surface, there are stronger winds coming out of the southwest or south of southwest. So at the surface, where you have winds coming out of the southeast, about 5,000 feet higher, we have winds coming south of southwest. Higher than that, at 500 millibar level, that's 15 to 18,000 feet, we have winds coming due southwest. So surface out of the southeast, 5,000 feet higher out of the south of southwest, add another 10,000 feet to it, coming out of the southwest. Increasing with height, increasing with speed as it increases with height. There's some good shear there. We have natural rotation in the environment. So it's pretty significant wind shear in this region ahead of this cold front. There's a lot of moisture available from the Gulf being right there. We have this wind shear, this natural rotation of the winds in this region. We have the cold front approaching, wedging itself under this warm, moist air, forcing it to rise, forcing it to encounter that wind shear as it rises, as it condenses, as it precipitates. And then lo and behold, and there's very finite instances, conditions were just right. All of this plus more conditions were just right that unfortunately there were 2 to 3 tornadoes that did occur in this region. Preliminary report suggests 3 tornadoes, 2 in Mississippi, 1 in Alabama. There was some significant property damage, but as far as I can tell, thankfully there were no deaths in any of the tornadoes. But that is kind of the review here of how this system outbroke. So it was this primary low pressure that brought this winter storm into the Midwest. Along its cold front, a secondary low began to form further south. And that secondary low was able to kind of command the rest of that cold front in this region with a lot of instability. So there's a lot of moisture, there's a lot of energy in that region, and a lot of wind shear, so changing direction with height. It forced the air to rise. We got severe weather, we got storms, and then we ended up getting the tornadoes as well. Which made it pretty interesting. Now, you might be thinking, tornadoes in February. How common is that? Well, I don't know what the statistic is off the top of my head. It ranges. I can tell you those severe storms and specifically tornadoes in February aren't unheard of. You're more likely to see them in the South than you are in any other part of the country at this time of the year, but they're also not overly common. It seems to be every few years there's a decent outbreak in the South in February. But every year there are tornadoes in the country in February. So again, we're kind of in that transitory time between winter and spring as things are starting. There's more sunlight each day. Should be warming up, even though we're about to be plummeting temperatures up here. But we're in that transitory time within the weather. So severe storms in February aren't unheard of. And last year, up here in Columbus, we had 5 tornadoes in February. the weather's weird. It's not unheard of, but it's also not overly common. So we're in that transitory time here. Weather's about to start getting really interesting here as we head into spring severe weather season. So I hope you'll stick around and enjoy some more reviewing of the weather as more and more outbreaks and severe weather starts occurring here over the coming weeks and months. As always, I appreciate you listening. Please leave a like and a comment if you can. Subscribe to the show, whatever platform you're listening on. Consider sharing it. Send me a DM. I'm on Twitter at @TheGavinWhiteWX. You can email the show. You can leave a comment. I believe if you're on Spotify, you can comment on the individual episodes now. That's new. Everywhere else, you can leave a review. You can get in touch with me and let me know your questions, comments, concerns. I'd love to talk about them. But as always, I appreciate you listening. Have a good week, y'all.